This is going to be a quick video demonstrating how I would design an arm guard for a quadcopter using Fusion 360 with the intent to use this for 3D printing. So the way I like to start this, so this design, I have a tracing of the arm that we want to work with. This is a trace made for me by actually one of my good customers who needs an arm guard for a quad that I don't have. So we take that tracing, we're going to use that as a guideline. So the first thing I need to do is get that tracing into Fusion. And what I like to do is start by having a reference sketch just to give me some straight lines and such to work against when I bring in that image. So we'll create a new sketch, we'll do it on the bottom. And what I need here is a rectangle with my reference dimensions. And the reference dimension I have here is the width of the arm. So we are going to create a quick rectangle. And we can do that either using R for rectangle. You can also use the rectangle button in your menu bar if it's there, or in the drop down you'll see menu. And I like to use the 2-point. Doesn't matter, I'm going to type in the dimensions. So I'll start at the origin, just because that's what I like to do. And instead of trying to stretch it out, you'll see the height is highlighted there, so I can just type in 16.25, which is my reference height or width for the arm. The other direction on the rectangle doesn't really matter because I'm only really worried about the height, and this is again just for reference. The reason I want a rectangle is I want to have something to line the arm up with. The arm width is 16.25. I'm going to line the arm up across so that it makes my design work just a little bit easier. Just kind of my preference. So the next step is we stop that sketch and we want to go ahead and insert the image. So we insert, we do attach canvas. What that'll do is that's going to stick the image underneath what we're doing so that we can use it for tracing and such. So I'm going to put it on the same plane as we did for the sketch, and we want to make sure it's on the back plane, not the sketch itself, because we're not going to use the sketch beyond getting things imported. So we've picked that face, and then we have to go select the image. So I'm going to bring up this image file, and you'll see it is there. I'm going to zoom in a little bit here. You'll see it's there, but probably a little bit small. So one thing we want to do is kind of look at it so you can see what we're doing. See if we can get the orientation right first. It's about 45 degrees off, surprisingly pretty darn close. Gonna guess that it's not quite right. Looks like maybe not quite 45, so we'll adjust. Yeah, it looks more exact. And then we want to bring this up because we're going to use this as a reference. Let's see if we can find that point, probably about here. Looks good. We'll get that reference right on there, and we'll keep that. Hit enter to save it. You can hit the OK button as well. And then now we still see that obviously the size is not quite right. So the next thing to do is scale this canvas to the right size. What we do is we go into canvases, we right click on it and go to calibrate. Then we need to pick 2 points on the canvas and tell what they should be. So the reason we use this vertical line is so I can make sure that I give 2 points that are actually vertical from each other. And I'm going to zoom as far as I can. And remember, this is a tracing, so this outer line is going to be the outside of the thing I'm actually tracing. So we'll put the first point, say, on the inside of that trace line, and then the other point we're going to put on the inside of on the other side, but right on our vertical, so we know that we're most likely the right place. And then we're going to change this dimension here to 16.25. And that's going to enlarge our canvas till it's, now I'll zoom back out, so you'll see it actually matches that block a little better. Now we can move it again if we want to. I'm going to just to show that, but also because I kind of like to have it. So you hit edit and it allows you to move the canvas. I'll move it up till, actually move it a little bit this way as well, till we're seeing that 16.5 again is where we want it to be. If we zoom in, we'll see. Yep, looks pretty good. Okay. So now one thing I do want to remember with this particular work, I want to keep all my lines on the insides of the outer lines, since it's a tracing, or on the outsides of the inner lines, since again they are tracings. So we are happy with that there. So what we're really looking to do is put an arm guard on this arm. So the first drawing we're going to simply hide. So we'll go to this first sketch. We'll rename it to reference so we remember why it's here. And then we'll hide it. And then we want to create a new sketch right on top of this thing so we can actually design our part. So sketch, create sketch. We're going to do it on that same backing plane. We need to turn back on our origins. For some reason I got turned off. Pick the bottom origin, and we've got a new sketch. So what we will do is we'll take a look at this part of the arm. And again, I like to zoom as much as I can on whatever it is I'm trying to work on at the time. And I'm going to start with the center circle just because circles pretty easy to get right, especially since most designs that I've worked with tend to use very standardized dimensions for things like circles and slots. So we will create a circle. I like to use 3-point circle. Again, this is tracing, so the circle will be inside the actual part. Now when you're trying to find the points here, you'll find the snapping can get very annoying as you're trying to get on the edge there. So hit command and that turns the snapping off as you're moving around. And we can put, so we're going to use the 3-point because it makes it easy to figure out the size of an actual thing. 2-point, if you don't get two completely opposite points, you get a little messed up. So we're just going to grab a couple of fairly sharp points on this circle. Try to make sure we're in like kind of the same part of where the fuzz happens. So we'll put the second one here, and then the third one we'll put over here. And what you're going to find is when you get all in place, you're pretty close to a real dimension. And what I tend to assume is that these are actually specific size circles. It's probably not. If we hit the dimension tool here, dimension, pick the circle, it's probably not 6.484. It's probably 6.5 to be exact. I find that these assumptions are usually pretty accurate. So we'll turn off the dimension tool with the escape. Select the circle, and now we can just make sure it's perfectly centered here on the drawing. We'll get that now. Be honest, this probably won't get me 100% accurate, but it'll get me darn close and probably good enough for a workable tool. We can do kind of the same thing, and we got another nice circle here that's probably another nice specific circle. So I like to start these with a circle as well, so we'll do the 3-point circle again. And again, now in this case, this is the outside of the circle, so we want to get on this side here. We'll go, say, here and here, and then we'll bring in this third point here. And I'm going to bet we're looking at, again, hit dimension, the wrong thing, select this circle, dimension. I'm going to bet we've got a 10.5 millimeter circle, so I'm going to grab it and do that and use that as my reference. I think we're going to be pretty safe with that. Realistically, you can do that with almost any part. In fact, these two sides are probably a circle. So let's see what happens there if we do. We'll use a 2-point circle this time just because, well, we don't really have another edge, and we're going to have to try to get fairly close. So 2-point circle. And this is tracing, so we'll go here. Here. And in fact, it's probably very safe to say that this circle is going to be concentric with this other circle. And again, probably a specific size. One. Maybe. I'm not sure on that. And of course, seems that we've kind of moved off of where we want to be. Let's get this one back. So we'll select the circle and we'll move it. But make sure you use your command when you want to move something not real lot. Recenter this. I think that's going to be it. I don't like the 29. It doesn't look quite right, does it? So let's make that. Let's try 30. Too big? Much too big. 29.5. That looks pretty close. It's quite possible that the tracing is not perfect. This happens. The other thing we were going to look at is these are probably lined up pretty well. So we can take a look at the line from here to here. And make it vertical, or horizontal, I should say. I'm going to go with it. I'm tending to believe things are usually pretty well symmetrically designed. If anything, it's going to be our drawing that's off, or I'm probably slightly not, the canvas is probably not quite aligned properly for where we're at. What I'm going to do now is put in what I think are probably fairly round circles here as well. So let's do another circle. Circle. Here. Oop, not there. 3-point circle will be easier. 3-point circle. Let's start. Let's start here. There. There. And we will assume that these are mirrors. So we're going to then mirror this one, mirror this part, get selected, and we're going to mirror it, select the mirror line, and we'll mirror it across this line here. And that should give us a pretty good idea of what our arm ends look like. And then I'm going to give us some straight lines here. We'll do some line from here to here, and assume that our designer did what I would do, which is make this line tangent to both of these circles. And this is just kind of making some assumptions about what the designer would do as he designed his parts. They can be wrong. Designers do sometimes just freehand things and get crazy. My experience is that doesn't usually end up being reality if you're looking at well-designed parts. So again, we can also do that with these circles, right? Let's make sure we fix up our circles to be tangent with each other so that they're edge to edge. Circle, tangent to its brother. And as far as we're blown up, that's going to be pretty useful for us to make it pretty easy to see. So we need to get this same line in down here. So we'll line from a point on this circle to a point on this circle, and when we tangent it up, it will make more sense. We'll tangent again from here, here, and you'll see that gives me a pretty good shape. In fact, if we turn off the canvas, you'll see it's starting to look a lot like that arm. So I'm also looking at this and assuming that we've got some symmetry back here. So let's do this. Let's put in a line as a reference, using this whole center point as a reference. We'll come up here and start and drag it, keep it vertical, down. Turn this into a reference line, so double click or right click, make it a construction line. And we're going to assume that this line and this line mirror across that. So sketch, mirror. We've got two selected. Select this mirror line. Oh. And guess what? I think our assumption's wrong, so we won't do that. So since we see that, what we're going to do instead is we're going to put a line just from this circle, and we're going to yank it back here. And the first thing we're going to do with this line, we're going to stop. We're going to make it tangent to the circle, because we know that it has to be, because of the way the design works. And then we will drag this endpoint around till we like where it's at. So I'm going to zoom this in a little bit more, just to make sure. Yeah, see, I think that's pretty darn good. And just to make life easier for ourselves, I think we'll probably stop the guards there. Again, let's make some assumptions. We're going to assume that this guy is designed with some rational design points in mind. So we're going to select this one line to mirror, and we will mirror it across this same dividing plane. And you'll see it comes down here. Okay. And just to finish the design basics off, we will bring across the bottom here. Boom. So now we have kind of all the shapes we need for the basics. We do want to get in these are screw slots, so let's get these in real quick. This is going to be fun because we're going to use some cool tools with this. Let's start with our circle again. Circle. 3-point circle, because that's the one that does us the best job for these. Let's zoom real far and let's find the one that's smoothest sketch. I think this one looks pretty good. So we will go boom, boom, and boom. Let's see. Again, I'm going to bet on this being, I'm going to bet on that being 2, because, well, it's made for M2 screws. So we'll go for 2mm. Or, sorry, M4 screws. So it'll be, that's kind of small. All right, M2 screws. So that is probably what we're looking at for the slot. And I'm not seeing how it can be really much different. So again, we'll move this a little bit, get it lined up really, really good. And again, since this is a guard, probably not a big problem if it's a little bit bigger anyway. And we're going to actually kind of cheat here because we know that both sides will be the same. We're going to copy it and paste another copy in. And move it to this other end. And it looks pretty good. Okay. Good. Throw some lines in and make them tangents and get our ellipse. Line, line, tangent them up. You'll see when I drew that one, I happened to have it in just the right position to be tangent, so I went ahead and took it. If you can get your eyes to work well enough to get that to work, you're in better shape, but hey, look, this works. So now what we're going to do, since we're again going to assume lots of symmetry and good design, instead of having to do this over and over again, actually one of the things I want to do right now, since we've got that, I actually want to go ahead and clear this up to make it just a ellipse. So we are going to trim parts of this down to get rid of parts we don't want. Actually, let's use break instead of trim, so we can break this circle. Oh, we're not in sketch mode. Somehow we got sketch. Let's go back to editing the sketch. Edit sketch. Okay. Now our trim tool will work. Now we can use trim. Trim off this inside, trim off this inside. Boom. We have an ellipse. So the next thing is assume this is a nice even pattern, and we're going to select this, and we're going to create a pattern. So we'll use a circular pattern. We've selected our objects, and then we're going to select a center point, which will be obviously the center of this, and we'll change it to 4 copies, and we'll see that that comes darn close. Tells me that maybe that's pretty close. Maybe we're a little bit rotated, but we're going to go with it and see how that works. Again, sometimes the drawing is not perfect, so we assume designers are symmetrical and clean and neat, so we'll get pretty close there. We can also see that even the tracing, we can see that that one was a little bit narrower in this, so could be some deficiencies in the tracing as well. So it looks like we have most of our basics. What I really want to do now is assume I've got everything right, and we're going to clean this up to make it one design. So that means getting rid of all the lines that aren't really outlines of our part. So I'm going to use that trim command to remove a whole bunch of stuff that is not part of our design. So we'll get rid of that piece there. We're going to get rid of this piece out here. Get rid of this piece in here. This one here. And you see now we've got that nice shape going on. And then here we can kill the innards of this circle. Now one thing we'll want to do is we'll want to put these dimensions where they'll make a little more sense, so we don't have them extending dimension lines. We could actually change this one if we want to make this better. Instead of a diameter for what's really just an arc, we can remove that, and if we just remove it and put in a new dimension in place, we'll get a radius, and we shouldn't have to reset it because it will pick up where the size currently is. It makes it pretty accurate. We can do kind of the same thing here. If we want to make sure things don't get screwed up as we go, it's not a bad idea to go ahead and put in dimensions on these other radiuses, just so that they stay. We could probably even fix a few of them like that one to be the 1.5 it should have been, probably. I'm going to bet that was 1.5. Interesting, this thing got turned around funny. Yeah, well, we could turn this into 2 radiuses as well, which I think we will, just so it stays looking good. Dimension this arc to here. We'll dimension this arc to here. Good. All right. Good. So now we have our design, and if we turn off our sketch, you'll see now we have a pretty good design of what the bottom panel of this arm guard needs to look like. So the arm guard needs to have some part on the outside of the arm. So what we will do now is add a border, a boundary around the outside. If we can, the offset tool is perfect for this. So we then go ahead and pick. Look at that, perfect. Except we want to go the other way. And let's say we want, now one of the things when I'm designing for 3D printing, I like to make sure that thin walls like this, like up the side of an arm, are going to be some multiple of the nozzle sides. So in the case of this, I know that this is going to be printed on a 0.04 nozzle. So I'm going to make this 1.2 to make it a good protective arm. So that's 3 times the 0.4 nozzle. We'll go ahead and do that, and boom, we have our outline. Of course, we won't use the back here, but still useful to see where that's going to go. One thing to make sure that we can now have the right things to extract out, we want to use the extend command to then cut off the back sides of this piece, and then we can we can now go ahead and remove some pieces, right? So we can do that. We'll use our trim to kill the places where it went beyond the end, because we wouldn't have a wall on the back side of the guard. Now the other thing that we need here, and actually the reason I was asked to do this design, is we want a little lip on the top. So the lip's going to have to come in from the edge of the wall. So we're going to use that offset again and grab this curve and come in. And I'm going to go with, let's go with 1.6, which will be 4 shells in 1.6. As the lip. And you'll see that would give us a pretty good idea what our lip would need to look like. Now, once we've got some of these shapes in, especially this one that's not really where it has to cover the arm, it's more about how it's going to fit on. We can make this nicer, so I'm going to kind of give this some roundness, and we can try using the fillet. Sometimes it'll work. There we go. I like the fillet. So let's go ahead and fillet that, and if you control or command and pick another curve to go with it, they'll get the same size. And I actually kind of like that default 1.5, so we'll go with that, and that's going to be our overhang. And there we kind of have our whole design. So the next thing to do is actually build this up into a 3D part. So I'm sorry, one thing we do need to do right here, we see they're not closed through, so we can't select a panel there. Let's extend those out to where they go. And there we go. All right, now, next step is our actual extractions. So I'm going to make this so that the bottom of the guard is 1 millimeter thick. And we'll need 1 millimeter. So what we're doing is we select that particular profile, and we extract it 1 millimeter. Or sorry, extrude it, not extract. Extrude with use the E key. You can use the commands in the command bar. Go 1 millimeter, and you'll see if we turn this sideways. Oh, now we've got the bottom side of the guard. All right. Now put our drawings back on so we can see what we're doing. Every time you extrude, it'll tend to turn off the drawing so you can see the part you're drawing. And actually, we made a small mistake here, right? Because we had this lip drawn in. The bottom of the guard actually has to go up and cover that up too. It has to actually go out to this outside part. So what we need to do is edit this extract command and add in the rest of the bottom. There we go. And now you'll have, boom, boom, there's your bottom. Put the walls up past the side. One of the things that I like to do here, since I'm not actually 100% sure of the height of the arm, or for that matter how thick my customer wants this bottom, I'm going to use some parameters. Parameters are cool. Parameters allow you to make things parametric, so you can actually change things as you go and have the whole diagram keep up. So we add a user parameter here, and the first thing I'm going to do is add guard bottom thickness, which is going to be that 1 millimeter that I put in the bottom, so that we can actually make that changeable later, and I'll show you how that works in a minute. And then we're going to add arm thickness, because I'm actually not sure. I'm thinking it's a 4 millimeter arm, but it might not be. We'll need that. If we make that parametric, I can fix that really quickly later. And then just to be even more parametric, we'll get a thickness for the lip. So lip thickness. I'm going to go 1 millimeter to start, just to see how that comes out. So now I have some parameters. So the first thing I want to do is fix this bottom to use the parametric value that I put in. So we edit by double clicking on the extrude here, and we change the distance to be our guard bottom thickness that we just added. Now it's still 1 millimeter because that's what it was, but that's exactly what we want. So now the side of the guard, what comes up the side, is going to have to be the thickness of the arm. plus the thickness of our bottom layer, plus the thickness of our lip, so that we cover the whole range. So what we're going to do is a new extrude command, E for extrude, select all the profiles that make up, and this is done by selecting and the shift to select more, all the profiles we want in that, and then we can make the distance. We can do it here, we can select it here, but we can also just do it here. Go distance, and we want this to be guard bottom thickness plus arm thickness plus lip thickness. And there you go. Now you've got your sides. So far, really simple, right? Now the next one is a little bit trickier. We want to put the lip, and the lip needs to be up here. But you could do this two ways. You could draw a new drawing at this level and extrude the other way. I like my drawings to be consistent and have everything I need in them, so we're going to come the other way from the original drawing. And what we're going to do is we're going to do another extrude command, and let's select all the stuff that is that lip. And you'll have to probably pick through here. Now, if you can't select the thing you want, hold down your mouse and it'll let you pick from a selection. And you'll see here, we can pick that whole face, which is not what we want. We can pick a different face that was not what we want. What we want is that profile. There you go. So that'll let me pick that one. I want to pick this one as well. So we go to the profile here. Now you see we have it selected. And we know we want it to be that lip thickness, right? We don't want it to cut though, and we don't want it down there. We want it up at the top here. So we need to move it up. So we'll change it from being profile plane to being offset plane. And we want to offset it by guard bottom thickness and the arm plus the arm thickness. Now you'll see that moves it up where we want it. And you'll see Fusion's smart enough to realize that you change to a joint at this point. Sometimes it doesn't, you know, or maybe it's not what you want to do. Maybe you want to do something different. Maybe you did want to cut something. In our case, we do want to join and make it all part of one big part. So we'll go ahead and hit OK. And now you'll see we have a completed design for an arm guard. So what I'm going to do now is I'm going to save this. And then to make it printable, well, we can do a couple things, right? Just export it out as an STL file, so we can find the body here, which is going to be under bodies. This body, right click, save as STL, and that'll give you the printable STL file. Just make sure you get the right thing picked, and hit OK. Give it a name. And save. Now, what's cool about that parametric stuff that I did is if you realize that, let's say, the arm thickness was not right, or we want to make the bottom and top thicker, we can change that now really quickly without having to rewrite anything, no re-extrude. We just go into Modify, Change Parameters. And now let's say the arm, let's say it's a 6mm arm. We can just put 6 here, hit Enter, and you'll see the whole design change right behind us. If we want to make the top and bottom thicker, we can make the bottom 2mm thick. You see it fixes the whole thing. We can even make one parameter reference to another. So if we want to make the lip match the bottom, we can. And that just, boom, everything follows. And then if we change this one back to 1, you'll see both the lip and the top change. You know what we didn't do? We can make this even more parametric. Let's go ahead and look at our sketch real quick. I think we might be able to make this even better. So let's get the sketch. And if you remember right, this width here was the width of our sides, and we don't have that parametric yet. So let's try this. This is going to be kind of interesting. Add a dimension there. Let's add a dimension here as well. So what I want to do is I want to add a parameter for the wall thickness. it's going to be 1.2. Okay, and we'll change both of these to be a wall thickness. But let's see what happens if we change that now. So if we modify the wall thickness, we'll change this. Let's say we wanted to make it another shell deep. So make it 1.6. And there you go. Everything worked just the way we want it to work. So now we can modify the whole design. Really, we can make it, heck, make it 5. Make it 5 millimeters. All right, boom. It's going to work. And you'll see if we finish this, stop the sketch, go back to our design. Oh yeah, everything moves the way we told it to. So that's super cool. Now this whole design is parametric, and we can modify whatever we need to as we need it. Let's make that wall back to something that actually makes a little more sense. There you go, see? Boom. We can even do the same thing if we want on that top lip. So we'll go ahead and add some dimensions there as well to give us the same level of control from and this is all because we're basing off of that central design, which was the arm diagram itself. There you go. We'll add a parameter for that one as well. That's going to be the lip overhang. Again, now we come out of here and we change that lip overhang with the modify. We should see it get bigger and smaller. Boom. Oh, looks like the bottom didn't follow, so we probably need to add a couple more dimensions there to make that work. So it looks like we need to add the bottom ones. Oops, not wall thickness. I want that to be the overhang. And we can even add a dimension to this one if we want to just be really sure that things do what we want them to do. And this is going to be this one plus the lip overhang. See? Now, if we change the lip overhang, come back out of here. Change lip overhang now, we should get a clean change. So modify, change parameter, lip overhang, and let's make it 4 to see how crazy it gets. There you go, see, works perfectly. Let's modify it back. Now the cool thing about this is now I can get one of these printed out, have my customer try it out, and if it's not quite right, almost everything here is parametric. What isn't, we can adjust pretty quickly, and if we need to add parameters to it, in fact, if he comes back and says, hey, that circle's wrong, or these are wrong, I'd probably come in and throw a parameter and fix those up, and fix them up, maybe change the distance here, or what have you. But this is going to get us pretty darn close. So that's it. thanks for watching, guys. Hope you enjoy. If you like what you see, I plan on doing more of these, so subscribe. You'll also see other cool videos from me for different things. I will be doing some product reviews. You'll see my flying videos. Enjoy.